Um, okay. Hello. I think everything is working fine. Okay, we are live now. Right, welcome guys. Good evening. Um, so I would like to go over what we started yesterday. Um, I was trying to solve this merge sorted array question, and seems I couldn't get the solution. So let's go over it again, and I'll attempt it for the second time. Um, let me. This is a solution that I, made some time ago, but I still don't understand how I solved this. But anyway, let me just collapse this and try to understand the question, clearly. Right. The question says you are given two integer arrays, nums1 and nums2, sorted in non-decreasing order. So both arrays are sorted, right, from um, small number to bigger number. So it's just increasing order. And two integers m and n, representing the number of elements in nums1 and nums2 respectively. So two integers m and n. Okay, right. Merge nums1 and nums2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m element denotes the element that should be merged, right? The first m element denotes the element that should be merged, and the last n elements are set to 0 and should be ignored, right? Okay, and should be ignored. All right, so what this question is saying, we need to I need to understand this question very well. So let me just remove this. I'll remove that, and yeah, let me just put this side by side. It's actually interesting how this question is easy, right, in terms of logic, but actually coming up with the code is where we have a little bit of issue. But yeah, let's try and understand the question again. So the question is asking us, right? Let me just put it this way. Let me expand this a little. Can I drag this down? No, I can't. Okay, so let me just copy this input here. Let me see if I can paste it here. Oh, well, I can. Right, this is cool. Okay, right. So the question is asking us to do specific things, right? First of all, let's understand our inputs. Let's understand what they mean. So, from my understanding, right? Okay, let's go this way a bit, and yeah. So from our understanding, they are asking us to merge nums1 and nums2, right? Well, they're asking us to merge nums1 and nums2. Before we understand nums1 and nums2, let's understand these values here. The m of nums1 and the n of nums2. let me see, nums2, right? What do these values mean? Well, in this part of the problem, it says the final sorted array, right? Before we even get to that, it says and two integers m and n representing the number of elements in n1 in m representing representing the number of elements in nums1 and nums2 respectively. So the number of elements in nums1 here, right, is m. Now, regardless of the size of n, nums1, what the question is basically telling us is the number of elements that we want to put into consideration is m here, right, for nums1. And I'll just say first array. I don't like saying nums1 all the time. It's kind of difficult for me. So the first array here, right, has these values in it, all these elements in it. But the question is telling us that we should put into consideration m, right? M elements from this array. Regardless of the size of this array, we are only going to consider m elements, right? And the value of m here is 3. So we are going to consider the first 3 elements in the array, which is 1, 2, and 3. Of course, this is in increasing order or non-decreasing order, right? Because if we were to put into consideration 0, then it's no longer in increasing order, right? This is just like something to confuse us a little. But yeah, once you understand that you are only going to work with m elements of the nums1 array and n elements of the nums2 array, that is fine. So you already understood about 40% of the question. Now the next thing to also look at is so they are also asking us, right, to merge this nums1 and nums2 together. Now what they basically mean is let me just call this a merge, right? Merge should be equal to every item in within this range here, right? So it's like we are taking a sub array from this first array here. So we are taking an m elements from array 1 from the first array. So that would be the value of m is 3. So 1, 2, and 3 elements, right? I'll call this a1, right? And then a2 is simply the same thing. So how many n elements of the second array should we take, right? How many n elements? So how many elements? N here is 3, so we'll still take 3 elements. So this 2, 5, and 6, right? So we are merging basically a1 plus a2, right? But then we also want to merge them in in a sorted order, in a non-decreasing order, still from small, because both arrays are sorted, right? But regardless of the fact that they are both sorted, there are some numbers that appear in the second array or the first array that might be bigger than the second the other one, vice versa. So it goes both ways. So how do we now go through this, how do we go through the first item, the first array here, and the second one simultaneously, right? And merge and place each item one after the other. So this is basically what we are I'm saying. How do we do this? So we have 1, we compare it to the item in this second array, right? 1 and 2. 1 is the smaller one, so we put 1 first. Then we move to the second item. Now you can see that we are using the first array to point or look through the um the the second one, right? But you can also do it the other way around, and I actually prefer using this the second one, because we are merging the second one into the first one. So let's keep the first one in place and then merge the second one into it. So what we will do is we'll start from this item here, and we'll check, is any item here the same size as this one, right? Or smaller than the one in the first array. If it's not, we'll put the first array item there, and it goes the other way too. So anyhow you want to do it, you can just choose to do it that way. So we go with 1, and then we compare, is 2 bigger than the first item here? If it is not, then we just we just increment, we just put both items there. So 2 and 2 will go here, 3 will come before 5, and then 6, right? Now another best way to do this programmatically, right, since we know that we are merging the size of this array, right, which this sub array A1, which will basically contain m elements, right, we can just say, okay, let's get the size of this array already, right? So that will be 3 plus 3. This will give us 6, right? I'll call this length of L of merge. So L would represent merge. L merge, right? The length of the merge is equal to 6, right? Now we want to merge the what the question says we should do is the final sorted array should not be returned, right, by the function, but instead be stored inside the array nums1. Okay, so array nums1 has to stay in place. So we are just going to keep it, nums1 here. Nums1 has to remain intact. We are not touching it, right? So at the end of the day, the length of num1 should be equal to the length of this merge, right? Okay, so what do we do next? We can then take let's say, so we know the length of our last array, right, or n1. So it's equal to 6. Okay, since it's equal to 6 and everything is in increasing order, that means we can start inserting from the back. We can start looking for which word is the bigger element, right, in either array, and then insert it into nums1. So what we will do is we'll take the first how do you call it? We'll take the last element in nums1, right? So this will be 3, because the amount of items we want to use in nums1 is equal to m. So how do we get the mth element from this array, right? In other words, how do we get the last element from this array? So it will just simply be, I'll put end 1. Let me just put end 1 should be equal to m minus 1, and the last element from this second array too will be sorry, the last element's index, right? I'll put end index and end, let me not confuse, end index 2 here will be n minus 1. So each time we compare, right, we'll compare with the last item. So let me just, I can't copy this. Okay, let me put it like this. Okay, I can't go below this. Right. All right. Okay, that's fine. So, this here's what we are going to do. Um, I'll simply say, okay, let's look through and add to the end of the array. So the end of the final array, right, is nums here. This nums here, nums1, right, and this value here. So the first time we compare, right, we'll first compare. We'll say, okay, is nums1, right, nums I hate saying that word, nums1, right, is nums1, the last item in nums1 will be what? Will be this end index here. So end index idx index, right? If this one is bigger than the one in num2, right, and end index 2, if this is bigger than the one in the end index 2, what do? We'll now say, okay, nums at, so we want to append it to the end of nums1. Nums1 is basically the last result that we want to merge all our items in. So nums1, right, nums1. So what is the end? It is the last merge. So l merge, right, should be equal to this one here, right? Should be equal to this one here. So we will say nums1 and the last index here. So nums1 and let me just put this very well, l merge. So yeah, end index 1 like this, and then we will do the same thing. So in the case where num2 is now the bigger one, we will also do the replacement like this, and every time we replace to the end, we have to decrease the last merged value, right? So we'll have something like this. Let me still do it here again. So in our first iteration, we'll have something like this. So we are comparing from the back, right? We are comparing from the back. So we'll start from here, right? We'll say, is this value, oh, what's that? That's strange. Okay, so we are going to do something like this. Let me just start here. We'll say Christ, why is this thing lagging? Okay, now we're good. We'll start with so our final nums 1. Let me use a different color. So here's what we are going to do. We are going to check the last item here, right, and compare it with the last item here. Now we know that the last item here will be the value of m minus 1, right, because this is at the second index here. So we'll also compare it with the one at the second index here, although this value is just a coincidence that they are just, you know, 3 3. Otherwise it could be any other value, right? So which is why you need to do n, you know, the last index here. I'll just say, let me just call this right, and no, this is left. Left is equal to n minus 1, and right is equal to m minus 1. So we take this one and we compare, right? We compare it with these two. We compare the right end to the left end. If the right end, right, is bigger than the left end, where's my left and right? Oh my god. Okay, I'll just confusing myself. So let's put this as left, and this is our right. Right. So if the left end is bigger than the right end, we already know that that is going to be the last item in the final nums1, right? So nums1 will also look like this. We know at the end of the day, nums1 is the value of the items that will be present in nums1. The total item in nums1 will be L plus R, right? So we'll do something like this. So nums1 at the end of the day will have a value of what? This is 3 plus 3. So it is 6. The length of nums1 at the end of the day will be 6. So we have 6 slots here. We have 1, 2, 3, 4, 5, and 6, right? So each time we compare, right, because we want to insert from the end, each time we compare the last item in this, sorry, that's not the position, the last item here to this one here. If this one is bigger, whichever one is bigger, we are inserting it here, right? So we'll do something like this. We'll say, we'll do it this way. Okay, so if 3 is bigger than 6, we would have inserted 6, but 6 is bigger than so 3, so we'll put 6 here. Then we decrease this one by 1, and we also decrease this one by 1, so we are at the index 1. Sorry, after doing this comparison, right, we only decrease 1 first, so whichever one that has been inserted gets decreased. So we inserted 2. Where is this eraser? Okay, so let's erase this, right? So then we'll move our pointer to this point here. So we are at this position here. We already inserted this one. So whichever one we insert, we decrease, right? So we inserted 6. Now we compare 3 to 5. Which one is bigger? 5 is bigger. So we do 5 here. And we move our pointer to this point again. Oh. Okay. Let me just leave it like that. We'll move our pointer to this place, right? Then we compare 2 and 3. 2 and 3, which one is bigger? 3 is bigger than 2. So we put 3 here. Now we compare 2 and 2. So after inserting 3, we move, sorry, this is 3, this is 5. After inserting 3, we decrease the value of this one here, 2, right? So it becomes 1 here. It moves to this point, so our pointer will be here. We'll compare this to this one here. So we have 2, and then we're at this index. So 2 and 2, they are all equal, so we insert both like this. And then this one here is done, so we don't need to even try and compare, because we are comparing against, you know, an item that is out of bounds. So here we don't even need to do any comparison. We just say, okay, is this one here the, you know, a bigger one? Yes, it is. So we just put it here like this. So this will be our final sorted array. All right, let's get into the code side and see how we can implement that. let me copy the prompts. Question. So we are going to copy here, right? Where is this? Where am I copying from? So I'll copy. This is my solution yesterday. I've already done it, so let me just walk you through again. So we are starting, the while loop from the end, right? The end of nums2, right? And then we are using a while loop basically. So we first of all compare if we are currently at the end of num1 or at the start of num1, which will ultimately return 0, right? This is the index. So, and we compare, the item at nums1's end, which is going to be 2 from start, with the one with the end of nums2, right? And then we'll also do if this condition is true, right? If we are not already at the end of num1, if nums end is not nums1 end is not already equal to 0, and nums1, the item at nums1 end is superior at the item at nums2 end, then we want to put nums1 end at the end of the array. So we take nums1, last end is basically the last item that is going to appear when we combine both arrays, right? So this is basically going to be the last item. M plus n will give us the length of the array, but to access the last item in an array, we always do -1. So which is why this -1 is there. And then we just take that item at that index and set it to our current end, right? And we'll see we'll have this value here reduced by 1, right? Because after inserting, we want to move our pointer to the right, no, to the left. We want to move the pointer by 1. Okay, which is why we are reducing it, so that we hit 0 and then we stop looping. So if this case doesn't work, we're either seeing the larger item in the second array, or the item is basically equal, right? They are equal to one another. Then in that case, we will just do this. We'll say the last nums -1 last merge, right? These values are just crazy. You know what, let me just solve this again. Let me just write the code. I'll do that very quickly, and because I'll need to provide this code in a GitHub repo as well. I've not been sharing my GitHub repository for the questions I've been solving, so pardon me, I will do that very soon. Okay, let me import this name. Yeah, so let's say end index 1, right? End index 1 will be m-1, right? And end index 2 will be n-1 as well. Sorry, -1. And then the last item index, the last item let me just write everything out so that it actually makes sense. The last item in final nums1 index should be equal to m plus n, right, n minus 1, right? So we'll now use a while loop. So while we are not already done, we can use any of the arrays, right? So while end index 2, right, let me use end index 2, right, is still superior to 0, right, is it superior to 0, then we can check, okay, are we already we can first of all compare the item at this index against the item of the second array at this index, right, before we now set it to the position where they have to appear in this final nums1 index. No, in this final nums1. I think I'm doing a lot of, okay, so the stream is still going on. So here is how we're going to do it. Before we even make any comparison, we need to be safe, right? We need to know that we've already hit the end mark, so there's an edge case to that. So if nums1, right, at this index here, so index 1, right, sorry, if index 1 is superior or equal to 0 and nums1 at end index 1 is superior to nums2 at end index 2, then we want to swap, right? So this already warranties the fact that we can, you know, swap. I mean, guarantees that we can swap this item here. So nums1 at the last, you know, index should be equal to nums1 at this end index 1 here, and then we will decrease end index here by 1 since it is our pointer. So plus minus equal 1, and then we'll say else what do? We'll say nums1, right, nums1 at this last index here. No, sorry, if this condition is not met, what we want to do is we want to just insert the item of nums2 at this position here, at this index here. So how do we do that? We'll just say nums1 last index should now be equal to nums2 at index of nums2 here. Then we also decrease nums2 by 1, and regardless of whatever happens, we always want to reduce the last final nums index because we want to move it to the next item to accommodate the next item that is coming in. So let's say last item final index minus 1. Okay, so this is the solution. Let's go ahead and run this. And okay, so where is it? LeetCode, yeah. Okay, maybe this will make things a lot easier since I'm using like proper wording. I hope it makes more sense. Sorry, I didn't copy the variables. It's okay. Why did I even do that? All right, everybody makes mistakes. Okay, so run this, run. run this. Now you can see it passes this test. But what is the time and space complexity of this solution? Is this the best time? Is this the, you know, is this the worst time? So what is the worst time possible that we are providing in this solution? This time complexity. Well, the time is really based on the size of the input, right? So nums 1 and nums 2, because we are always you know, we are making this operation based on this arrays here, the first and the second array. So the time complexity will be the total of the addition of these two. So yeah, that's our time complexity. And in terms of space, well, we are not creating any new space in memory. Already this is in linear space, so we'll say it's two linear spaces because we have, you know, this first list and this second one, so O of n. Yeah, in terms of time it did well. In terms of memory it did not. Interesting. Anyway, let's not waste too much time. We've already wasted half. Let me try another question. I'll just go like this. The next question we'll do is this Pascal's triangle. Pascal's triangle. Mind you, I've never solved this question before. No, never, ever in my life. I made that mistake now. Okay, this is a funny looking animation. I hate the fact that it's going back and starting all over again. Okay, let's read the question. It says, given an integer num rows, return the first num rows of Pascal's triangle. In Pascal's triangle, each number is the sum of the two numbers directly above, as shown in this one here. So here is their answer. If you've been given 5, you will return 1, which is this one at the top here, and the other ones are just the addition of the two numbers directly above it. So we'll have the second array will be 1 1 1 1 1 2 1 and 1 3 3 1 1 4 6 4 1. Pascal's triangle. Well, what does this really mean? Let's see if I can do something. Okay, let me understand the question very well. Let's say we are told if we've given an array, so an integer nums, right? So let's just use this ones here. So n row, I'll call this nr, is equal to 5, and from this 5 we'll have to create a 2D array like this, right? Let me just copy this. A 2D array like this one here. A 2D array like this. Well, this is tricky. We have to create a 2D array. Okay, so basically we create an array and insert the array in a bigger array. So we have something like this. We have a bigger array. First of all, we want to return a bigger array. This is how I think about my solution. We have a bigger array, But then inside this bigger array, we want to return an item here, which is an array of every element. Wait, hold on. Let me start over again. So let's understand this result here. At the end of the day, we want to have an array with arrays inside of it, right? An array with a lot of arrays. What's the size of this array here? Let me see. 1, 2, 3, 4, 5. I'm trying to create a pattern here. So we know that at the end of the day, we want to return an array with 5 arrays in it. And the size of each array is also in this same order. So we have 1, 2 again. The size of this one too is 2. The size of this is 3. The size of this one is 4. And the size of this one is 2 is 5. Okay. Oh no, I'm not erasing that one. So I just erase these ones here. Okay. So what do we do now? Well, if this was like hold on, let me think. Let me think about this solution. We have 5 people in the chat. Okay. Let me just have like 2 minutes to think about this. Well, for me to really picture this well, I would want to have this array in a vertical form. So I'll have something like this, 1, 1, and then the second array should be something like this, 1 and 2. The third one will be like this, 1, 2, and 1. The fourth one, so I can really see what I'm doing. I can see the pattern in terms of array. So 1, the sum of the last 2 above it. What's the last 2 above this one here? Well, if we say above, right, it should be something like this. So there is really nothing above this one, is there? There is this one. Okay, so we have 3. What's above these 3 is 2 and 1, so it is 3. And what's above these 3 here? You are not looking to the left. Okay, let me just write it out the way they said it in the question. So the way it was stated, sorry for my bad English. Alright, so we have 1, 4, 6, 4, 1, like this. Okay, so we have a triangle now. I can see clearly what I'm about to do. All of this is the entire array, by the way. I just tried to separate it to see. First of all, how did we create the second array? We need to understand how each array how each of the array in this final result is created, is constructed. So they said in the question we are told that each number is the sum of the two numbers directly above it. So this one here is the sum of two numbers directly above it. So directly above this one, we don't have any other number, right? So this will be 1, right? This is just 1. So the answer here will be 1. But how did we get to? How did we get to? Is it that we are looking at the previous directly above it? Me, I would say this 2 here was derived probably by combining. When you say directly above, is it like, okay, so this 2 here is at index 1, right? So is it the one in front of it and the corresponding number above it from the previous array? Is that how it is? Is that how it is? That's not how it is. First of all, let's recognize a pattern here. I can see that we have, like, 1 1 1 at the going down and 1 going down like this. So which means every element is going to start from 1, right? Then we have the second list will start from 1. Wait, I see. Hold on. This is about. Wait, is this question really easy? Well, let me just trick my brain. Okay, so I can see that every array here starts from 1. And if you look closely here, right, we can also see like a form of pattern. We can say, well, this following one should be 1 plus the one above it, right, which is 1. This will give us 2. And then when we are here, we also start with 1, and then we look here, we add this 2 is 2. But how do we? Okay, we also add 1 at the end, but that is not correct. Oh, see what I did? This is 1 here. Sorry, this is 1 there. We have 1 here. Okay, good. So I would say, first of all, we start from 1, right? In the second iteration, we have to add. So this first iteration will probably be 0, right? We'll start from 0. Then, or we'll say, okay, when the iteration is, we are at index 0, sorry, we are looping based on this value here, right? NR, right? Which is the number of rows that we want. So NR, right? So we start from 1. So when NR is at index 1, if we are on the first row, we only want 1 item. On the second row, now the second row means 2 items in the row, right? Let's take it, brick by brick. 2 items in the row. So, and 2 items in the row, second row. So we'll have, we know that we want to append 1 at the end of the array regardless of what is. So we start from 1, and then we also add 1 here. I don't know if this makes sense. And we can do something like, so we are 3, so which means this has to contain 3 items, right? It has to contain 3 items. Okay, wait. What if we say we we need to append 1 at the end of the array, and then this we are on the second row, right? So the second row will have an index of what? Of 2, and then we'll say, okay, 2 minus 1. This will give us 1. And then we are the third row, we always add 1 there. And third row is 3, right? So meaning we want to have 3 items here. We'll perform that same operation, which is 3 minus 1, which will give us 2. And how do we get this, the last one? So since we're at index 3, right, row 3, then we can just do the answer we got here, which is 2, right, minus the index of the row. So we will have 3 minus 2. This will give us 1. Okay, we're at index 4 now, so meaning we want to have 4 items in this array. I don't know if this works. We want to have 4 items in this array. We always start from 1. We append 1 to the array, right? And then the next, how do we get the next number? So we are at index 4. We'll always do what? We always minus 1, which is 3, right? Now, how do we get the second 3 here? Well, I said we always minus the last operation by 1, right? So this will give us 3 again. No. Wait. Index 4. If this is x, how do we get 3 from 4? So we will just do 3 plus 1. Interesting. We are at index 4, right? We want to have 4 items in the list. Want to have 4 items in the list. So what do we do? Yeah, if we are appending 1 to the list, first of all, before making, the current row number minus 1, 2 minus 1. Okay. R minus 1 is equal to 3. Then what if we say R minus 1? We just do R minus 1 twice, right? Why do we have to do it twice? That's another question. Why do we have to do it twice? Why do we have to do it twice? Because if this was 3, right? Oh, okay, hold on. So numbers divisible by 3 and 2. So let's say I do the same operation twice. I have 3 here, and I'll just add my 1. My 1 is basically the last item I have here minus the row. This is not, I kind of recognize it. Okay, so how about the last one? How do we do it? The last one will be 5, right? So meaning we'll have 5 items in the array. So it will be what? 4. This will be 4 here because we want to do minus 1, as we always do, the row number minus 1. But now we have 6 here. and we said we'll repeat the same operation twice. That's not gonna work. Okay, what if we actually want to look to the left and right? What's on the left of this one here? If you look on this image, right, I don't have anything to draw on this screen. Let me see if I can put this here. Okay, I can. Wow, super, 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 super. Oh, awesome. I I don't like seeing this animation. It's just annoying. Um. Okay, let me push this to the top. Okay, let me push this here. Okay, let me push this here. Alright, and bring this one in view. Oh, you're still here. Sorry. Right. I said the previous element, the current array is built by looking at the left and right of the element. So what's the so we'll always start from 1, right? What's on the left of this one? There is nothing, right? So what if we do something like this? Plus nothing, plus nothing. There's nothing here too, so this will also give us 1 1. Alright. I'm trying to find the pattern here. Does this work? Let's copy the array again. Okay. So we have 0 0 on the right here. How do we get 1 1? If I don't get the answer in the next 5 minutes, I think I'll have to look at a solution. How do we get 1 and 1 here? Well, if there's 0 0 here, does that mean this array will always have 0 0 0 0? Because they say we should look at, the left and right top sides, so above it. So what's above this one here? I think I should make it here like this so that it actually looks better. What's at the top of it? So it's going to be first. Oh, we want to have something like this. So the first array is going to look something like this. We have 1, so there's nothing above this one, so we start from 1. The second array, let me draw this first array. It's too close because I'm going to come 1 1. So the second array was at the top of this one here, so we'll then use that, add it to this one to find this, right? So this will be 0 plus 1, which is 1. 0 again on this side because we have 1 here, so 0 plus 1 is also going to be 1 here. Hey, am I getting the solution? So here we have what? We have also 0, right? There's nothing here, so we do 0. Let me use a different color. We use 0 plus this one here, right? It will give us what is here. Then to find what is here, so we'll have this, something like this. So I have 1, and then that's the first one. to get the second item, which is here, this is supposed to be 2. What is above these ones here? It is 1 and this, so we'll add these two together and we'll get 2. Whoosh, we are getting there. I hope this works because I'm kind of confused right now. So when we have 1 and the next one is just 0, so it's 1. Okay, this is clear, getting clear. So if we have 0 here, basically the answer is going to be 0, is going to be 1. So there's no need to even worry about this part here. So the next one will be here to this side. Aha, this will give us 3. So we'll have 1, 3 ahead. From then here to this side, this will give us another 3. Ah, this thing is working. Okay, so this will give us another 3 here, and then here to here, basically 1 to 0 is 1. Whoosh, I think I'm getting this. So if this is 0, we are always inserting 0, so there's no need to even perform this calculation. I think this part here is irrelevant, right? It's just irrelevant, but it's still important. It is still important to know that we are looking somewhere versus somewhere, right? So yeah, at the end of the day, we'll have something like this. Here, this one will give us, this plus this will give us 4. That's correct. What is it? It is 4. This plus this will give us 6. And this plus this will give us 4. Right, that's the solution. Okay, so we have 4, 6, and 4 again with 1. Sorry. Can I code this? I'm not sure if I can. I'm not sure because how am I going? I'm definitely going to use a nested loop at this point. I'm definitely going to use a nested loop. Ah. Let me remove this. Okay. I think I'm going to I don't know. Let me look at somebody's solution here and see what they did. 3 approach, beginner friendly. Let me use the one that has Python tag. Yep. Using recursion. We have not even studied recursion yet. Well, recursion is just a function calling itself. A function calling itself. Oh, intuition. In Pascal's triangle, each element is the sum of the 2 elements directly above it. We can use a recursive approach to generate the triangle. The base case is when num rows is 1, in which we return either 1 like this. Otherwise, we recursively generate the triangle for num rows minus 1 and then calculate the current row by summing the adjacent elements. I don't get. Let me see your code, bro. So this is the recursion here, and this is combinatorial. What the hell is that? Combinatorial. So using recursion, previous rows generates num rows minus 1. So first of all, he said if the row is, so these are just some edge cases. If it is 1, just return this. So previous row self generates num rows. So self.generate is the same function here, right? So it's calling this function again. So it has to use the self, so that the self points to this class here, and this class has generate. New row is 1 times nums row. And what is nums row? Nums row started from 0, 7, 1. Nums row nums row minus 1 is how we are calling the function. I don't think I understand the code yet. I'll come back and find out more. So let's solve one more question. Pascal triangle 2. I'm not going to attempt that yet. I'll leave it for some time in the future. So string valid palindrome. So this is string manipulation basics, right? So let's look at valid palindrome here. So I'll copy this and Google search it. Duplicate. And this is the valid palindrome here. What does it say? This is our last question, by the way. I think I've taken enough time, but let me just solve this one and close for the day. I kind of feel sad that I couldn't get to the solution of this question, despite code wise it's not really clear to me, because I'm saying there's 0 on each array, and is that allowed? Am I allowed to put 0 at the end of each array every time I'm done looking up? I don't know. Okay, so they're asking us, a phrase is a palindrome if after converting all uppercase letter into lowercase letter and removing all non-alphabetical characters, it reads the same forward and backwards. Alphanumeric characters include letters and numbers. Alphanumeric characters include letters and numbers. Given a string S, return true if it is a palindrome or false. So we have this input here. A man, a plan, a canal, Panama. So if you reverse this, you have something like, if you remove all the all these other characters here and you look at this, if you reverse this will give you a pando. You will still write this the same way you write this the other way around. Okay, well, for something like this, so how do we know if this one is not an alphabetical character? Let me see. It's not alphanumeric. Numeric Python. How to check if a number is not alphanumeric is alpha num. Okay, so there's a function that does that. The is alpha num returns true if the character is alphanumeric, meaning alphabets that are A to Z, numbers 0 to 1. Example, characters that are not alphanumeric. Okay, so yeah, so it's alpha num, right? Is alpha num. We don't, okay, test it. That is alpha num. Is this is alpha num for the whole character? Now, geek for yeah. Okay, so it has a time complexity. Is alpha num. Wait, I want to see for myself, right? Let me use this. What's the name of this problem? Valid palindrome. Valid palindrome is our question, and we want to do something with valid palindrome. Our time has gone. Let me give myself 15 more minutes. Yeah. Okay. 15 more minutes plus the other one. That would be like 24. So 25 minutes. Okay. I'll say. Let me see. Name is equal to. Name is equal to. Let me say name is equal to. This string here. Sorry, this string. Arrange. Right, and I can see for I in arrange. Oh, for I in name, sorry. In name. Right. Print I dot is alpha num. Let's see if this works. Okay, it says true. But let's say if I had like a star here, what will happen? Okay, it says it's false. Right. Alright, there's a reason why I'm doing that, and because the question clearly says that, a palindrome is a word, right, that when written backwards reads the same as, writing it forward, right? So let's use a simpler palindrome, right? What I want to create, okay, if I wrote something like this, let's say our P here is equal to R-A-R, right? R-A-R, if we write this backwards, we'll start with this one here, which is R. The second one will be this, which is A, and the third one will be this one, R. Although we've reversed this, right, they are still, in the same position, right? So this actually makes sense. Okay, so the reason why I'm looking for a if how to check if a number is alphanumeric. Um, a string is alphanumeric or a character is alphanumeric is because you can see this place here. They added some comma and all of that. But at the end of the day, here's what they did: they removed everything, right? All the trading spaces and commas and any other thing that is not a letter or a number, and then gave us this new string here. So that if you reverse this, this will be written the same way as it will be read the same way as this. Okay. Um I'm thinking, what does reversing mean? Reversing is basically having the last item as the first item, right? So last would then become first. Okay. Last will become first and first will still become last. It doesn't matter. Um, can we, is it possible, let me see, to have a dictionary with the same key? Let's see, the item is equal to um, S S S S Y. S is 1, Y is 2, and then S is 3. Yeah, there's an issue here. What does it say? It contains duplicate keys. Is there a problem? Is this a problem? Well, it ignored 1. And we can't do something like this. We can't do something like this because it won't work. It won't work like that. So what if we had a tuple with the hold on. What if we had a tuple with this different so this is 1. I'm still thinking, alright. Okay, and now this is not gonna work. Honestly, what I'm thinking of doing is, let me explain my solution, my idea. So here's what I was thinking, right? Here's what I was thinking. I wanted to create a map, right, of each of these items and their indexes. So I'll have like R, right, and then it's at index 0, and then A is at index 1, and R is at index 2, right? This is my map. Then I can now loop through the original array, right? The original string, sorry, the original string here, and check the index of each of these elements. But I want to start from the end here, right? The end here, the item at the end has to have a value here in this map, and its value has to be the start, which is at index 0. So if I say for I in P, right? For I in P, okay? For I in P, and let's call this our map X or map M. Let's just call this M, right? Now the condition will be, right, to look into M with the current value I, and if the value here, wait, sorry, we are not doing for I in P, we are using the range. We want to look from the back. Range, we are starting from the len of this thing up to -1, so it will stop at 0. The length of this array here, this P here, len of P, right? So we'll check if the item at this index here, right? So I can also have like this X here, which is like an index tracker, right? So I'll say if P at I, right, P at I is in is in our map, right? If P at I is in our map, and if P at I is in our map, and then we already know it's in the map, so there's no need for this check again, right? There's no need for this check. We just want to see the value here. So how do we do that? We'll check if so how do we check for R? So if the value at R here we're starting from the end. Yeah, so if we're starting from the okay, we need PI here. PI here will give us the current element, right? But how do we check the current element here? It is also M of this one here, right? If this value here is the same as this our tracker here, I'll call this tracker. If it is equal to the tracker, then we are good to go, right? We'll just keep the loop going. But if it is not, we'll return false. We'll return false. Otherwise, we'll keep it going. We'll increment the tracker each time. So the next time tracker will be 1 plus equal 1. So here is equal to the tracker, sorry. This will be tracker. Our tracker is, let me put TR here, TR here. So we'll increment it every time, TR here. Right. So how do we create the map first of all? So that means we will have 2 loops. So I'll first of all create the first map and then carry on with the rest of the work. So let me create the first map. I'll say so for I in um, in range of s, the length of s, sorry, the length of s. So we are starting, let's start from 0. So yeah, for I in the range of s, this is okay. I'll create a map here. Map is equal to this. So what I'll do is I'll say, okay, our map should be, at I here. Sorry, not at I, but at SI. At SI should be equal to I. So the current index, right? Now, when we are done creating the map, what I want to do now is to loop through the array, right, itself and compare it with this one. So I said I will have a tracker here. So I'll say const tracker is equal to 0, right? So I'll start from the end of the array down. So for I, let me see if I'm still doing the same thing. So I'll start it from the end of the array. Okay, right. Let me just push this to this side and bring this one here. Okay, I'll say for I in the range of, so we want to start from the back, right? Want to start from the last element. So we are starting from len of s minus 1, len of s minus 1, yes. And then we want to stop at minus 1. So want to stop at minus 1. So now we'll say if the map, right, if the correct item at the position where we are now, so if the last item here is not the same as the value of the tracker in the map, then we will return false. Otherwise we increase the tracker, and then at the end of the day, if we are done looping through, we'll just return true, since we didn't find any. So we'll see what's the value. So s of I, right, let me just use j, and say map of j. I don't know if this is a built-in function. I have a feeling, so let me just put it map x. Okay, map x of j. This will return the value of the item there in the map. So if it's at index 0, it will return 0. If it's at index 1, it will return 1. I'm still skeptical about this due to the fact that you can't have duplicates in a dictionary. So duplicate keys. So let's say map x is equal to, if this is not equal to the tracker, right, the tracker, then we want to return false. Otherwise we just increase our tracker. So tracker plus equal 1, and then we just say, okay, return true, it is a valid palindrome if we did not return false at this point. Let's run this and see what will happen. Yes, this is returning true. Why? Because of the way we are building the map itself. Yeah, I see. So here's what we are going to do. We need to ignore the item of this map here. We need to ignore the items. Hey, let me work on this in my console first. In my editor here is valid palindrome is alpha num. Okay. What's the typo? All these fancy things, eh? Let me just. Fine, it's okay. We need to check if it's not a space and if it is, for I in range this and now if I to lowercase, hold on. All right, so sorry, okay, for I, so if I is, how did we determine that alpha num thing? Let me see. Let me change this to a string. Is alpha num, so I'll just put this back to I. So if I is alpha num, if I is alpha num, if I is alpha num, then we want to, do this, want to add it to the map only when it is an alphanumeric character. And then we want to also say, reduce it to a lowercase. If alpha is num, want to reduce it to a lowercase. Yeah, so this will give us the answer dot to lower, right? If it's an alphanumeric character, do this. Else, if we are tracking in the maps, right? So basically this will not work. So here's what we are going to do. We are going to do the same thing. So if j dot is alphanumeric, right? If it is alphanumeric, then we want to do this too. So we'll just say like this. Tracker has to increase. Here we return true. Tracker has to increase. If this j is alphanumeric, j dot lower, so we are reducing to a lowercase. Okay, I think this should work. This is my solution. Oh, crikey. You see, wait, if I in range, oh, if s of I, sorry, if s of I, right, is an alphanumeric character, and if s of j itself is just a number, so this is not gonna work. Yeah, let's test this and see. Okay, 2 cases passed. This is true, but this says I return true, even though it's false. Well, if j is an alphanumeric character, right? If it's an alphanumeric character, and if it's a alphanumeric character, come here and say, okay, is j to the lower case I want to see what's happening inside this place. Doesn't make any sense. We are almost 1 hour into the whole thing. I'll just run this solution. Solution is equal to solution is equal to solution dot is palindrome, and we want to use this one here. Oh, no way. Was it? Okay, I want to use race car because this is one that is failing, and I'm sure race car, right? See what I'm doing now. I'll just, oh my god, okay, solution here, and just cut this out. I'll say print solution dot is a palindrome. What am I doing? Jesus Christ. Ah. Okay. Okay. Let's just come back here. Copy the entire thing and just do it this way. Right, when we run this, it says it's true. Meanwhile, it is false. So what happened? What happened here? False. Wait, and J is not equal to maps lower. We also want to see minus J. Oh, sorry. So if it's equal to J, then this will always return true still. This is not true. I know what is happening. I know where the issue is. Let's first of all print our dictionary and see if we had a dictionary. Print maps. You see, this says arrow is at 9. Oh, I see. There is no duplicates. How do we get the duplicates? Blah, blah. Okay, what if I say to create the map, right? I can do lower plus, just like a string concatenation, right? Plus, let's say I. Will this work? It won't work. Plus the value of I. The value of I. There is this. How do you do this in Python? So print. I've forgotten this. Variable inside string Python. No, not this. Are you guys kidding me? There's a simple this is it. So F. So you put the F in front of it. So string formatting. Well, what if I don't want to format the string? And so I say str of 1, right? Then I now check, right? If this map to lowercase, right, plus str of the tracker, str of the tracker, because our tracker will start from 0. What if I do it this way? R0 should return false. S at J will be the last item, right? R is 0, the value is 0. A should be 1, it should be 1. C is 2. E, let me print it with the print the string as well. S. stop? How do you stop? Let's go back to our normal this thing. So we are starting. Where did we start from? We start from this. Okay, RO A1 C2 E3, then A5 C7. Instead of making a dictionary, why don't I just reverse it, and then just compare the last items? At least that's what anyone would do. I don't know why I'm creating a new space in memory anyway. So if I'm able to get this value here, right, I can even start from here. I can see this is, let's start, okay, let's even do it this way. Let's change this to a list, and then I'll say maps dot append this s of I in it, right? We're appending s of I in the map. Well, let me just reverse it instead. So to reverse it, I'll start from the end, -1 up to -1. Yeah, so this here, I'll just say for I in range then of norms, j then of norms, I'll say if j is an alphanumeric value, right? So j is alphanumeric, and I'll say, okay, if item at index of j is the same as the end of the index of I, our map here, then if this is alphanumeric and s at j is not maps, what is it, maps at j, we want to return false. Let's see, index error, out of range, maps j. Okay, so if this is alphanumeric, right, then we can now do our operation here. Let's say if, because this will be the same length as the other one, so if here is not the same, then we can now return how maps at j I see what's happening. All right, let's take a look at the solution. I really believed if I had taken my time to think about it, I mean, I already did that, it's obvious. So let's see the editorial. Nobody has provided any solution. Jesus. 100% memory, 2 pointers, the best. Interesting. Interesting solution. Mm, there's something wrong. All right. Everybody is using two pointer. Okay. C for C in I don't know. Hmm. Return all. What does this all mean? Guess I don't know Python. Jesus. Okay, that's it for today. I think I'll come back to this tomorrow. I have other stuff to do. Yeah. See you guys tomorrow.